All right. Hello, everyone. Welcome back to Comp 2150, Object Orientation. I hope that you're all doing good. I hope you're all doing good. I've been like running from one place to the next today. This is a me problem, not a you problem at all, but we have department council meetings sometimes, so we all meet together, all the profs and instructors get together and meet, but it's scheduled on Thursdays, and it's scheduled like in between my two classes. So I leave one class and then go to this meeting and then have to like run here before that meeting has even finished. They might still even be there, but I'm here because I like you. Yes, yeah. So let's talk about JavaScript. Last class, we started I want to make sure that's not feeding back. Is it better now? There's not a ringing coming from the speakers? Okay. Last class we talked about JavaScript, and the purpose of last class was basically to get our toes wet. Let's figure out how JavaScript works. Let's write some simple programs in JavaScript. And also let's start to see some of the weird stuff about JavaScript. As I said repeatedly last class, JavaScript is a forgiving programming language, and we are going to continue to see how JavaScript is a forgiving programming language today. The way that I'm structuring today's lecture is similar to last class. So I have a lot of slides here, but these slides are for your reference. They're for your reference. I'm primarily going to be spending a lot of time in Visual Studio Code just writing this stuff up. If you have got Node set up on your machine in between last class and today, great, that's really great. You can kind of follow along with what I'm doing in your own machine. If you haven't had a chance to get Node set up, it might be worth doing even in the next couple of minutes. It's a fairly quick thing to download. If you have Visual Studio Code already, it integrates fairly well with that. Alternatively, if you're feeling brave, you can edit stuff on the command line with VI on Aviary directly, because everybody uses VI, right? Yeah? You're all using VI? Yes? I hope you're using VI. I hope you, okay, you're using Emacs then, right? Yeah. Text editors, okay. If you haven't got Node set up on your machine, it's worth getting it set up. It's worth following along with what I'm doing just to kind of get your finger memory straight with JavaScript. Today we're going to keep going with JavaScript. The things that we're going to add today are objects and classes. That's the primary thing that we're adding to what we had done last class. So let's just get straight into it. So I want to start by taking a look at where we finished last time. So I want to refresh our memory about what's going on with some of the stuff with JavaScript. So I'm going to start at the top. JavaScript is a programming language. It's a programming language. JavaScript is a very forgiving programming language. One of the things that we added kind of closer to the end of the lecture last time that helped us out a little bit was this useStrict string. This is a statement that has the string literal useStrict in it. And what that helped us with was preventing things like using variables that haven't actually been defined yet. It turns that into a compile time error or a runtime error so that we don't get into unexpected states. We declare variables with let, but otherwise it looks approximately the same as what we were doing with our other programming languages. We have a name, we have an assignment statement, and we have a value that we want to assign it to. We use console.log to produce output to our terminal. You can do this in your web browser. There's a console in there. You can print stuff out to your console, and you can do most of the stuff that we're doing in your web browser, but we're mostly looking at using Node to do all of this stuff. This little example here on line 21, this is our example of basically, let's make sure that useStrict does something where we've got this variable that hasn't been declared before. We used it. We tried to make a change to something that existed. useStrict made that into an error for us so that we couldn't do it. JavaScript itself is a dynamically typed programming language. So when we declare variables in a JavaScript program, all we're really saying is, I want to use this name to refer to a value. We're not statically assigning a type to that variable. Instead, the way that typing works with JavaScript is that what the variable refers to at runtime is what dictates what type that variable actually has. So that means that as our program is executing, so on line 25, I declare a variable x, but it doesn't have a type yet. So when I run this console.log here, the value that I'm getting out from this is undefined. A variable that has not been initialized with a value has an undefined type, because it doesn't have a value yet. And the only way that we can get a value from a variable in JavaScript is to have a thing, have something that it refers to. When we assign a value of a string to this variable, its type suddenly becomes string. When we assign a number to this variable, its type suddenly becomes number. Unlike Java, and unlike C++, where we use that static type to say it has to be this type or something that is hierarchically related to that type, JavaScript is just letting us do whatever the hell we feel like. We can just put whatever value into a variable that we want, and that's what changes the type at runtime. Conditional statements and other control structures are generally the same, so conditional statements work the way that we expect conditional statements to work. There's while, for each style loops and return statements. We can iterate over arrays in two different ways, so using a traditional for loop and using a that's a little bit distracting. That's okay. We've also got for each style loops where we're declaring a variable and we're iterating over an array. And then we've got functions. And functions are a disaster. Functions are like this really weird mix of ideas in JavaScript. I'm going to skip over what I've commented out there for a second and just go past it to our add things function. When we declare a function in JavaScript, we declare it with the function keywords. It does not have a return type. I give that function a name, and then we can optionally name parameters. We can optionally name parameters, but they also have no types because we don't have types on variables. Within this function, we can do stuff with those parameters. We can call our function and we can get something back from it. So we can assign the result of a function to a variable. We can print out the value of that variable. We can pass any type of value into the function that we want to. JavaScript is not going to forbid us from passing a string into something where a number is expected. We can also do really weird things like not passing enough arguments to a function and passing way too many arguments to a function, and it just works. It just works. It just takes those values and either puts undefines in for the things that you're missing or ignores the rest of the stuff that you have there. The function blocks themselves have this extra variable called arguments, and arguments is an array of all of the arguments that have been passed to the function. So you can inspect what the extra values are that you have passed beyond the length of the named parameters that you've got here. And then you can do things like this commented out function where you've got, I want to pass however many arguments I want. I don't want to define how many I want to pass. I'm just going to accept none. And I can pass as many in as I want. And I can iterate over the arguments array and then accumulate the sum of the thing that I want to do. We're okay with arguments? Oh man, that is a mess. Yeah, okay. The main thing to remember about this is that arguments itself is just an array in a function. It's always available for you to use in a function. The value that it has is the list of all parameters that were passed to this function, or all arguments that were passed to the function, even if they're past the end of the named set of parameters. We continue along here. We've got arrays. We can declare array literals. We can also declare an array with a specific size, but have all of the values undefined. So this is similar to Java, where when you create an array of strings, for example, they're all null by default. There are functions like index of that let us ask what's the index of the value that I've passed in here. Concat will allow us to take two arrays and just stitch them together into one bigger array. And push will add things to the end of an array, so at the very end of the array, which is also telling us now that arrays are dynamically sized in JavaScript. Even though we've initialized this as a 10-element array, we can just keep adding more stuff to the end of it, and there's no issue with that. The thing that we left on was this kind of block of conditional statements. And what I was doing with these in class was just typing them into my Node interpreter one at a time, and I saw a lot of baffled looking expressions and like, what's going on? This is dumb. This doesn't make any sense. JavaScript is a language that will do something called type coercion. So I said that, but I wanted to put it in here in writing so that we can see what it actually says here. When you have arguments around something like an operator here that are of two different types, the language is going to change them into the same type before it does the comparison. So it's going to coerce one type into another type before the comparison is actually made. So in this first case here, where we've got 0, the number is equal to 0, the string, JavaScript is transforming the number 0 into the string 0 before it makes the comparison between the two of them. So it's coercing the type of one of those arguments into the type of the other to do the comparison. Likewise, with 0 and false, it's coercing 0 into a false-y statement, something that's false. This is not transitive, because when we make comparisons between two things that are of the same type, neither of them will be transformed. So comparing 0 to the empty string, even though the empty string is false, comparing the string that contains 0 and the empty string is not true because they're already both strings. There's no coercion that takes place. They just are comparisons of the values that you've got there. Generally, when you're doing comparisons between values, you want to use this triple equal sign. There's also a corresponding exclamation point double equal sign that says don't coerce types before trying to compare them. So we've got equals for equivalency, exclamation point equals for not equivalent to, and then the corresponding triple equals and not, and then double equals to do negation of comparison. Okay, so that was kind of a wild ride at the end of class, taking a look at these comparisons with JavaScript. And I just want to stop, catch my own breath, and see if there are any questions about that before we move on to other stuff related to JavaScript. Is it better with the lights on with the light theme or the dark theme? Does it matter? The bright's a little better. Okay. I sent an email to IST to ask them to please fix the lights. Please fix the lights. And then 2 days later, they emailed me back to say that's not our job. It's the physical plant's job to do that. We'll forward the request to the physical plant. So maybe by the time the class is over, like the course is over, the lights will be fixed in this room. Okay. Let's move on to talking about some other stuff related to JavaScript. So I'm going to save this as second.js. Got really creative names for these files. There's a couple of things that I want to finish with basic JavaScript stuff, and then after that we're going to move on to objects and classes in JavaScript. So I'm going to start by putting useStrict as a string literal expression at the beginning of my file to make sure that I'm not doing things like mistyping variable names. In terms of assignment and in terms of what variables are in JavaScript, remember that all variables in JavaScript are effectively pointers to something. Way back when we were talking about this idea of an object representation in memory, we had this idea that everything that's an object has this metadata about it. It describes in memory what type this value is. And in JavaScript, we have the same idea. In fact, that's kind of how the whole type of thing works in JavaScript. We ask for the type of a variable, and we refer to that object's actual value in memory and its metadata to decide what kind of thing this is at any given time. That means that you've got similar behavior to Java and C++ in terms of the way assignment works with objects that you're working with. So I'm going to say let A string is equal to ABC, and then I'm going to say let B string is equal to A string. So on line 3, I'm creating a new variable. I'm giving it the type string because I'm assigning it an object value that is a string. And then on line 4, B string also has a pointer to a string. I'm assigning the same value to this thing. If I say B string later is equal to XYZ, so if I reassign this value to something else and I print out those values, the thing that we would expect to see, the thing that I would expect to see is what we get as output. So the same thing that we're doing with Java. If we reassign a value, if we have a string and we copy it and then we reassign that value, we're not going to make changes to the original object that we were working with. The same thing is true, the same kind of expected behavior is true for things like arrays. So if I have let array is equal to a literal array that has the strings A, B, and C in them. And then remember, please, that there's no primitive character type in JavaScript. Strings are strings. There's no primitive character type. So using single quotes or double quotes will create a string. Even though I've only put one letter in there, it's still a string that has a single character in it. And then I later say let B array is equal to A array. We're copying the reference. We're copying the pointer between those two objects. So if I say B array at element 1 is equal to X, and I console.log each of those, then the output that I get here is it's changed in both places. So when we're just talking about primitive types, we're making duplications of the same thing, and then we reassign the pointer. We're reassigning the pointer to a different object. We're not making changes to the object itself. But when we're working with arrays, and then later when we're working with objects, it's the same kind of behavior that we see with Java and C++. The last thing that I want to do with basic JavaScript stuff is just a little bit of basic I/O in JavaScript. So this is the thing that you cannot do in your web browser. You can't do this in your web browser. The input and output in JavaScript is using libraries that come from Node.js itself. So it relies on your JavaScript interpreter to actually have these libraries built into them for them to work. So to do I/O in JavaScript, the way that we do that is we say let, I'm going to say I/O is equal to require and then fs. Require is a statement that's basically saying I am importing this library. So when we're thinking about Java, or C++, this is effectively the same as an import or an include statement. The difference between import and include in Java and C++ is that we're actually declaring a variable here. We're declaring a variable here that we're going to use to refer to when we're talking about methods in that class or in that library that we want to use. Idiomatically, so typically when you're writing JavaScript and you're doing input and output, you would declare this variable as I/O. You would call this thing I/O. But there's nothing really stopping me from saying something like Franklin's magical I/O library. I can call it that if I want to. There's nothing stopping me from doing that, but typically you would just refer to this as I/O. Later, when we actually want to do I/O, so I'm going to scroll back up here so that we've got that. When we're doing I/O with this library, some pretty common things that you're going to want to do are to read an entire file. So you can say something like let contents is equal to I/O dot. And then the function that we want to call or the method that we want to call to read a file is read file sync. So this takes 2 arguments. It's expecting 2 arguments to be provided to it. The first one is the name of the file. I'm going to ask this to read first.js, which is just the other JavaScript program that we wrote. And then the other thing that it's expecting is the encoding of the file. And we're going to just blindly put UTF-8 in here. File and character encodings, that's a whole course in and of itself. So let's just blindly accept that UTF-8 is the correct thing to choose here and just keep going with it. So this is going to read an entire file into contents. And then we can treat this like a regular string. So I can say console.log contents. Provided that first exists in this directory, I should be able to run second.js and then have it just print out the entire contents of that first.js. So I'm going to change this slightly. I'm going to say cat hello.txt hello comp 2150 control D, and I'm going to change this to say hello.txt, and then we'll get the same kind of output here. So I'm just reading a different file. To write to a file, I can use something similar. I can say io.write file sync. Write file sync is going to write. It will overwrite any file that exists with that name already. So I'm going to say here hello.txt. I don't actually care that much about this one. And what we pass as the second argument is what we actually want to write out to that file. So hello again. And this replaces any existing files. So if I run this, there will be no output here. But if I print out hello.txt, now it's been replaced with what we have put into that write statement. The other option is to call io.append file sync. Same thing, the name of the file. One more time. And I'm going to put semicolons to be consistent with my own rules here. We're going to run that one last time, and this time if I cat hello, it's appended to the end of the file. I didn't put a new line in there, so it's just kind of dumping it all on the same line. These two functions, all three of these functions actually, are ended with this string sync. Sync here means synchronized. What this means is that when you write a file, when you open a file for writing, this function will not return back to your code until it's finished writing the file. Similarly, if you append to a file here, it's going to go into this function and write the output, and it will not return to your code until it is finished appending to the file that you have opened for append. There are asynchronous methods, and asynchronous methods will just like take the input and immediately return back to your code and let your code keep going, even though it might be writing lots of stuff out to that file. For this course, I'm going to say stick with the sync versions of these things, just to keep things in order the way that you want them to. If you kind of go into other places, it might make more sense to use asynchronous methods, but just for now, stick with the synchronous methods. The last thing I want to kind of point at here is about the API that you can use for I/O. So this is the link in the notes. This will take you to this dark mode. You can switch it to light mode because it's very trendy right now to switch things to light mode. This is the entire documentation for Node's I/O library. So all of the stuff that we're talking about here for input and output, you can find more information about that on this link. And it looks a lot like the JDK. So there's lots of extra functions that you can be using for input and output here. Okay. We're good at file I/O. It's exciting stuff. I know it's exciting stuff. Yeah. It's kind of like 1010 again, but in JavaScript instead of, well, actually it's not like 1010 at all, because in 1010 you were doing processing. So it's more like 1020, but in JavaScript. Okay, good, excellent. Right. So the last thing that I want to talk about with the basic stuff is just my suggestion for how you should be organizing your code. I have just been like typing stuff in from the top to the bottom. I've effectively been treating this program as a read, execute, print loop, REPL. I've been treating this like me just typing in Node and then starting to slam statements into that and seeing what the output is from that. When you're actually writing a program, so you're taking the time to write an actual program in JavaScript, I would suggest that you use a certain structure for the program that you are writing. The first thing is use strict. That should be the top line of your file every single time. That should be the very first thing that you put in your file. After use strict, I would suggest that you have your imports, so anything that you're using require for. Anything that you're requiring here would go up at this spot at the top. So again, kind of similar to what you were doing with Java and C++. All your includes go at the top, so put all of your requires up at the top of your program. After you have imports, then what I'd suggest that you put is any functions that you've got that are not part of a class. So you're gonna want to write functions that just don't live in a class. And JavaScript gives you the ability to do that, kind of in the same way that C++ gives you the ability to write functions that are not part of a class, because it's got C lingering around in the background. Functions that are not attached to classes should come after your imports. Here's a function. We've got a function in there. After you've got functions, then what I would suggest you have is the classes that you're going to use. So I'm going to put this in here right now. we'll just pretend that it doesn't exist, but class my class. And then all of the stuff from my class, so class definitions here, class declarations here. A function that's called main. JavaScript does not call the main function as it starts. So in C and in Java and in C++, you have a function called main. I don't really know how much you get into in 2280, but the main function is the entry point to the program. This is where we're starting. I don't know if you've, I don't know what you do in 2280. I'm sorry, I really don't.
He says we don't need this, then teaches them.
Okay. 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 Well, you don't need JavaScript to live your life, but here I am teaching it to you. Anyway, that's a total digression. Gosh, I see that OBS is connecting and disconnecting, so I've got to really apologize if you're watching this on the live stream and I'm kind of cutting out. I'm suggesting that you write a function called main, but main is not a special name here, unlike C and Java and C++. I'm just suggesting that you call this function main for the purposes of consistency. So have a function that's called main, and then all of the stuff that you would do in a main function should go inside this function. So I'm going to take all of this stuff, I'm going to indent it by 1, and I'm going to put this all inside of my main function. The only line of code that you should have in your JavaScript file is the last line of code. Let me restate that. The only line of code that's at the kind of like the base level of the program in your JavaScript file should be at the very bottom, and it should be calling the main function that you've declared. In terms of the way that JavaScript is working, it's going to start at the top. It's reading your entire program, and then it will execute that last line. So it's reading and writing, it's reading all of your declarations, all your functions and stuff, so they are around for you to call, and then the only thing that you should be doing here is calling that main function. I don't have a good reason for this other than it's a nice way to structure a single file program. That's my main motivation for doing this. This isn't like something that you'll find necessarily in industry. This is just a good structure to have for your program. All right. The last thing that I want to show you that's just basic JavaScript stuff is some references, some language references. The two good language references that I would suggest that you be using are the Node.js documentation. The one that I've linked to here is not the same as the one that I was showing you just a second ago, but rather this is the documentation for the version that's installed on Aviary. Please remember that the version of Node that you can download from the Node website is significantly newer than what's on Aviary, but your code must work on Aviary. It must run on Aviary. So I've linked directly to that specific documentation just to give you a sense of what that looks like. The other place that I find to be an excellent resource is the Mozilla Developer Network JavaScript Guide. Mozilla is they're an old company. They're old in terms of like, the web. This is a really good website for introducing JavaScript. It's got beginner's guides and like intermediate and advanced, and it also has a pretty comprehensive reference on all of the stuff that we're going to be talking about in this course. So this is a good place for you to find other stuff that if you get stuck on something, it can help you out. Okay, that is our basic JavaScript. Let's switch to talking about objects and object-oriented programming. This course is called Object Orientation, so we should probably spend some time talking about A01 in JavaScript. JavaScript it's a forgiving programming language. We can create instances of our own objects without having classes. We can just blindly make our own objects without having structures, without having records, without having classes. Just make an object. It's a thing in JavaScript. We can and will talk about classes, but we're going to start by just looking at just objects in JavaScript. Objects in JavaScript are what is called a dictionary type data structure. I don't know if you saw, did you see dictionaries in 2140 last term? You did? Okay. Dictionaries are basically key value pairs. You got a key, and that key has a corresponding value attached to it. Other words that are used to describe dictionary are associative array, map, or table. These are all effectively equivalent to the same thing. You've got a key, and you've got a value, and you've got a data structure that sits behind that whole thing. We can make instances of objects in JavaScript using a special notation that's called JavaScript Object Notation, or JSON. You might have seen that acronym before if you're looking at web stuff, but we're just gonna do it. Let's take a look. I'm gonna make a new file called third. I'm gonna put useScript at the beginning. I am not going to be doing any I/O in this example, so I'm not going to require anything right now. I'm not going to be doing any functions in this program yet. I'm not going to be declaring any classes in this program yet, so I'm just going to immediately declare a main function. And I'm going to call my main function. And what I'm going to do is just start making an object. I'm going to declare a variable, and the notation to create an object in JavaScript is to use curly braces. So this is creating a new instance of an object. I can create a new instance of an object, and I can define properties and behavior on that object starting from nothing. I don't have to have a class as a background. I can just start making this thing. The way that this works in terms of a dictionary is that we've got to have keys and values. The keys in this dictionary can be strings. So we've got a person, we've got a name. My name is Franklin. The keys and values are separated by commas. I am using double quotes and single quotes interchangeably here just to show that you can. And I'm going to change this right away because I don't like the inconsistency. I want to use the same thing each time. So I'm going to put double quotes on name. My workplace is the University of Manitoba. And the keys in an object in JavaScript, you don't have to have quotes around them. The keys themselves, you don't have to have quotes around. So I can say something like favorite number. It doesn't have quotes around it, but that's still a key for this object. There's a math library in JavaScript. You can use constants in it this way. I've now declared an object in JavaScript just from scratch. I can start to use properties from that object. So I can say things like person, I'm going to say console.log. I'm going to print out person first. And I get some nice outputs, produces output for that thing. I can interact with properties from this object using dot notation. So even though I put it in double quotes in the definition of the object itself, I can just refer to the properties using dot notation. That's great, it's good, yeah. Objects are kind of weird in JavaScript. You're using strings in one place maybe, and then not using strings in other places. The other thing that you can do with an object in JavaScript is you can have the value for a key be a function. A function is effectively a piece of data in JavaScript. So I can add behavior to this object, and we've been talking a lot about behavior and classes and stuff and interfaces. We can add behavior to an object in JavaScript by defining a key, and then giving it as a value a function that has no name. So the function that we declared here is it's not named, it has no arguments right now, it's not accepting any parameters, but of course, just pass whatever we want to it. And then within this, I can do things like console.log this being a keyword that refers to the surrounding object that is in this function. So now I can call a function on this person by saying person.print. So print is the name of the key, and then the parentheses cause that function to be executed. I'm pretty sure you did function pointers in C. I'm pretty sure you did function pointers in C. It's kind of the same idea, where you can refer to the pointer of the function just by its name, and then you call it by adding the parenthesis after it. So if I run this code, I get the same output. I'm not doing console.log on the main part of my main function anymore, but I'm getting the same output because I'm just printing this object. And then the print property here refers to a function that's going to print stuff out. We can declare an object this way with static properties. So these are kind of defined at the time when the object is declared. And we also modify the object after it's been created. So I can do something like person.coffeecount, and I can assign that a value of 1. I've had 2 cups of coffee today. I've had 2 cups of coffee today. I can also do things like add new behavior to this object by assigning a function to a value. So I can say something like function, run coffee, how many coffees should I drink? And if I print this again, I've just added a new property to this object. I'm going to call this function. I drink 10 cups of coffee. There's a bug in our program. There's a bug in our program. What is this? Well, now it works. Oh, I just didn't save it. Oh my God. This happens all the time at my desk too. This happens all the time at my desk. I just don't have an audience for when that's happening. I'm still referring to this as the object. No, what's going on? Oh no. Thank you, thank you. I'm printing before. It's not even that I haven't saved it. I've just made an ass of myself. Thank you. Pair programming. Oh gosh. There. Okay, good. That's what I expected to see. Yeah. Okay, so what's happening here? Coffee count is not a number. I'm going to print it just before we call it the second time. And we're going to print it again after that. I'm going to make this bigger so we can see the output. So it worked the way that we expected it to the first time. It did work the way that we expected it to the first time, but the second time it didn't work. It just kind of broke stuff. How many people did their homework and watched that video called what? Nobody did it. It's only 4 minutes long. It's only 4 minutes long. Is it? Okay. Okay. When I call this function with nothing, okay, I was able to call a function with way too many arguments and way too few arguments. If I refer to a value here, I have a named parameter, but I haven't given it a value. Okay, everybody all at the same time. Everybody all at the same time. I'm going to do like 1, 2, 3. I'm going to ask you on the beat after 3, just so we're clear, the beat after 3. What value does a named parameter have if I don't give it a value in JavaScript? 1, 2, 3. Undefined. What is undefined plus 10 is not a number. We got a bug. We got a bug. I'm going to fix this bug because I think this is an illustrative place to make the correction. If arguments.length is greater than or equal to 1, if I pass nothing into this, that will be false. The arguments array will have length 0 if I pass nothing into this. If I pass one thing into it, then it's going to pass, that conditional statement will be true. Let's try running this again. We're going to run third here again. So the second time we call it, there's no change because we didn't pass anything. Excuse me, we didn't pass anything to that function. The other thing that we can start to think about doing is we can ask questions like, what's the type of something? So I'm going to say let my value is equal to undefined. So this is just in Node itself. I'm just running statements in here. I can ask this question, what's the type of my value? It's undefined. It's the string undefined. So I can ask questions like, if the type of that value is equal to undefined, that's true. That expression is true. If I really want to forbid things like lots, if I run this, I get 12 lots. If I want to forbid you from passing strings to my function, it's my job to check that you are passing things that are not strings to my function. So I would want to say something like, if arguments.length is exactly 1, and arguments at 0, the first element, type of, arguments at 0 is equal to number, then it's okay to call this function and do stuff. Good. Okay, great. Excellent. Suddenly types feel like you're getting a lot for free. In Java, if you tried to call a method that accepts only a string, you can't pass it a number. If you try to call a method that only accepts a number, you cannot pass it a string without converting that string into a number first, using something like integer.parsint. Here, it's on us to make sure that that doesn't actually happen. Make making objects like this it's kind of cool. It is actually kind of cool to be able to just blindly make an object with no other structure. We just start with nothing. Hey, an object is a primitive type in my language, and I'm going to base everything off of that. And you can just make new objects without having any kind of structure around them. Just add keys, make changes to it whenever you feel like, and then live your life and get on with stuff. That's good. That is good. That's a powerful thing to have, and it is a good way to exchange information between like a web server and a client, but it's kind of like all over the place. It's a little bit all over the place. We can add some structure to a JavaScript program by starting to use classes. I'm going to scroll up here. I'm not going to require anything yet, so I'm not going to add a require statement, but I am going to start creating classes in my JavaScript program. In JavaScript, to create a class, we use the class keyword, so similar to Java and C++ and Python. We use curly braces in the same kind of way that we do around other things. You can put a semicolon there if you want, but it's not a requirement in the same way that it is in C++ when you're declaring a class. Classes look approximately the same as the languages that we have seen before, in that a class has a constructor method. In JavaScript, you create a constructor using the constructor keyword. So we're not using the name of the class here, it's just literally the word constructor. The constructor thing is a method in this class. So it takes parenthesis there. I'm going to say console.log in constructor. And then I'm going to create an instance of this class in my main function. So I'm going to say let object is equal to new my class. The parentheses here are optional. So you don't have to put parentheses, kind of in the same way with C++, you don't have to put the parentheses there. You could just omit those and it will still call the constructor of that function. Parentheses there. Parentheses are optional. So when I run this, I create an instance of that class and I am inside the constructor. Instance variables in a JavaScript class are all public by default. They're all public by default. We can create private instance variables using a special prefix on the name of the variable. So a public instance variable is just outside the constructor. We declare it. We can initialize it with a value if we want to. A private instance variable has the prefix octothorpe, number sign, hashtag, whatever you want to call it. We can also assign that a value here if we want, but I'm going to say value, I'm going to take an argument in my constructor. I'm going to delete this console.log, and I'm going to replace that with assigning a value to this private variable in my program. The way that we do that is using the this keyword, and then you have to literally type in the name of the variable, number sign private var. The fact that the variable is named with a number sign as the prefix is what makes it private. We cannot get access to this from outside this class because it has a name that starts with a number sign. Yes, continuing weird stuff with JavaScript. There's no public and private keywords. It's just the way that you name your variables that says whether or not they are public or private. I'm going to say private var is equal to value here so that I'm actually assigning something to that. We can create methods on a class in the same way that we were adding functions. Yes, please.
the constructor also have an argument variable, so can you just pass as many arguments as you want?
Yes. We're actually going to get to that in a second. But to answer your question really quickly, yes. It is just another method. It's just another function. So it has access to that arguments variable. Yeah. I'm going to come back to that. I will definitely come back to that. I'm going to add another method to this object. When you add a method to an object, you don't prefix it with the function keyword. You just start by typing in the name of the method that you want to define. So I'm going to add a print method to this object, to this class. My print method is going to print out .log. Public value is, I'm going to rename this stuff. I want to make it consistent. Public value is, and then plus this dot public value, and then console.log. Again, including that number sign prefix on referring to that variable by its name. It's just named with the number sign as the first character of that variable. In JavaScript, private values are enforced in the same way that they are in the languages that we are used to. So I have this private value variable as an instance variable on my object and a public one. I can say object.public value is equal to something else. I'm allowed to do that. It is a public by default property. I am not permitted to do object.private value. It is a private value. It's enforced by the programming language to say that we cannot make changes to that property outside the class. A small note on private instance variables in JavaScript, a historical note. This is a relatively new feature in JavaScript. It used to be everything is public by default all the time. There is no access modifier for private. There isn't one. If you are looking at old JavaScript code, so you may find yourself in a place where you're in a job and you're looking at some old JavaScript code where you're doing maintenance on some project. If you're looking at old JavaScript code, de facto standard for private variables was to name them with the underscore prefix. But they were still just public. Everyone just agreed, if it starts with underscore, you just don't change it. It was not enforced by the language in any way. This is just something we all agreed, hey, that private thing is a good idea. Let's name some variables slightly differently and just pretend that they're private. But it wasn't enforced by the language. You could still make changes to those values. So if you see names that start with this underscore prefix, that's the intent of what that's supposed to be. Since this is a real grown-up feature now in JavaScript, you should actually use that number sign to say that this is a private variable when you're declaring variables in your classes. All right, the constructor. So getting back to what you're asking about, the constructor. In Java and in C++, we would write many constructors. We would write one constructor, the null constructor that has no parameters, and we would write a bunch of other argumented, constructors that had parameters, things that we would pass values into. In JavaScript, I'm going to delete this for a second. I'm going to comment this out. I'm going to say, by default, this is undefined, okay? And then I'm going to say constructor value this dot private var value is equal to value. That looks like a reasonable thing to want to do. I think. Yes, that looks like a reasonable thing to want to do. Unfortunately, though, a class may only have one constructor. You can only have one constructor in a class. Yes. Okay, good. Like, what were they on when they were thinking of this stuff? You can only have one constructor in a class. The way that you do this, have constructors with different numbers of arguments, is using the arguments keyword and doing it yourself. So, if I want to say that I have a null constructor, what I actually have to say is if arguments.length is equal to 0, then this private value is undefined. If arguments.length is equal to 1, then this private value is equal to arguments at element 0. If I want to have extra stuff, like setting my public value, I'd have to say if arguments.length is equal to 2, then this private value is equal to arguments at 0. And I'm going to put braces around this before I corner myself with a bug here. And this public value is equal to arguments at 1. And we'll just keep going. If I want to have more kinds of constructors, I just have to have this giant if-else ladder that asks how many elements are in the arguments array. Okay. Yes. Yeah. This is JavaScript. Related to this is that we can have functions in JavaScript. We have methods in JavaScript. But we can only have one method that has a given name. This is related to the whole idea of you can only have one constructor. I'm going to compile this, I'm going to run it. That works great. We're calling the print function. So let me scroll down to my main here. We're calling this print function. Actually, we're not calling this print function. Let's call the print function. Let's call that print function. I'm printing the print function. I'm calling the print function. I want to add a new print function. And what I want to add in this new print function is the ability to have a prefix. So when I print stuff out, I want to print that first. I'm going to just copy and paste this stuff. And what I really want to say here is prefix plus. And my goal is basically to say, when I call a print function slightly differently, I want to say object.print, and I want you to print this arrow in front of it, just to make it clear that like these are log statements or something like that. I've got both of those functions up here. It looks good. It's great. When I run this, we get undefined. That's hard to see. That's really hard to see. Let's make it even easier to see. Now we've got 3 copies of that prefix there. Oh, right. Okay, so now it's not a number. Okay, good. That's unintentional. That was unintentional. I was hoping to get undefined, but now it's not a number. Okay. In JavaScript, in a method, in a class, you can only have one copy of a method. You can't have methods that overload other methods. The method that we have here, the last one in the class, is the method. That's it. The other print method is just gone now. We can't refer to it anymore. The only way to simulate it is the same way that we did with constructors. We have to ask questions about the arguments array. So if arguments.length is equal to 1, then do this prefix. If it's equal to 0, let's do it this way. If it's equal to 0, then let's say prefix is equal to the empty string. And then kind of blindly go along with that. It's just entirely on us to do all of this stuff that we were getting for free from other features of programming languages. We can make private methods in JavaScript the same way that we could make private variables. So if I want to create a private method in JavaScript, I prefix it with that hashtag $. Now this is a method that can only be invoked within the class itself. So again, just the name changing it is enough to say that this can only be invoked inside the method, inside the class itself. JavaScript also has some nice features about having getters and setters, accessors and mutators to be able to make changes to properties without having to treat them as though they are methods. So I've got two values on this class, a public value and a private value. The public value is already public, so I can just make changes to it without accessors and mutators. The private value is private, so I can't make changes to it without accessors and mutators. I'm going to add a couple of methods in here, and what we can do is we can say set private value, and we can have a value passed into this, and what we can say is this dot sharp private value is equal to value. So this is a setter in JavaScript. What this gives us the ability to do is outside of my class, I can now say object dot private value is equal to something. And it looks like I'm changing the property, but I'm calling the method. I'm calling the mutator that I've defined on that class. So let's go back up here. I've added this method set. Its name is private value. It accepts one parameter. And what I can do with that is because it has this set keyword attached to it, I can treat it as though it is just a property, but it's calling that method on the class, that mutator method. Similarly, I can have an accessor and say get private value return this.private value, and then I can access that property outside of the class as though it were just a property, even though it's calling that method. If you have done Python before, this is similar to a property. It's called @property and then like something .setter in Python that you can annotate methods with. Okay. How are we doing? Yes, absolutely. I'm just like driving. I'm sorry. How far do you want me to go up? There we go. The names of these methods are coincidentally the same as the private value for the records. They don't have to be the same. I can call this something completely different if I want to. Well, I've got an unexpected token here on where private methods. I'm going to just remove that for now. There we go. So in this set and get, I can name these whatever I want. They're just methods. But because I've marked them with get and set, I can treat them as though they are properties. So I can use that assignment operator. So I can change this to be something completely different. Something completely different, and as long as I use that as the property name on the object, then that's the method that's going to be called. Normally we would name it the same as the private value, just kind of in the same way that we would name accessors and mutators in Java and C++.
You go back to the point where you call it object dot.
Yep.
Did you define? Okay.
down there. Okay, so let's do a couple more things. We're going to go back up to my class definition here. JavaScript has class variables and class methods in the same way that Java and C++ have class variables and class methods, and it's using the static keyword in the same way that Java and C++ are doing it. So I can say something like static count is equal to 0. This is now a private static class variable. And if I wanted to do something like keep track of how many instances of this have ever been made, I would refer to that using the class name as the prefix and not this. So in kind of in the same way as Java and C++ dot sharp count plus plus. In Java and C++, you don't have to use the class name within the class itself, but in C++ you do. In Java, you don't. In JavaScript, you do. You can do the same kind of thing with a method. So I can have a static current count. This creates a class method where I can refer to those values, and then I can call it on the class itself. So down here, I can say console.log and call it like a method. That's great. In JavaScript, we have const as a keyword, but const doesn't protect classes and objects. It doesn't protect classes and objects. So I cannot, well, I actually just can't, straight up can't have a static const thing. It just doesn't let me do it. It's a syntax error. And if I do use const on variables later in my program, all it prevents is reassignment of the variable. It doesn't prevent me from making changes to properties within an object. We can simulate static class variables, public static class variables, using static and the accessor. This is really dumb. This is really, really dumb. We can say something like static get pi, and we can return 3.141592.6 here. Return a literal. That's the only way that we can have static class constant variables. That's the only thing that we've got as a choice here. I'm going to leave you with one last thing. One last really dumb thing about JavaScript. It's actually kind of a cool thing. I'm going to call this file fourth.js. I am on fire with these program names today. I'm going to use strict. I'm going to break my own rules here just because I want to show you something before we leave for the day. We've got this array type, so I can say things like let my array is equal to new array. I can say that I want it to have 10 elements in it. That is great. That's really excellent. JavaScript is what's called a prototypical language. And what that means is that when you have classes and types, you can change a class after it has been created by somebody else. Array is a class that has been defined as part of the language itself. It's just there. You have access to this class. Somebody else has written it. It wasn't you. But if you don't like the way that array works, you can say things like array.prototype.owner is equal to, I would like all instances of array to have another property. I'm just going to get that. I would like to change the behavior of the push function, and I'm going to say I don't want it to actually allow things to be added to this array. what is going on there? You know what? I broke the environment because I changed how array works. I broke the environment because I changed how array works. Yeah, yes, that is awesome. Prototype. And then we don't get to see anything because I haven't assigned it to anything yet. Okay, so I've declared this new array. It's a bunch of undefined things. My array.length doesn't change because I haven't added anything to it because I changed the behavior of the array class. That's what I wanted to show you. That's it for today. Thank you for sticking around with me to see weird things in JavaScript. And I will show you just a little bit more about JavaScript in terms of classes next week. And I will otherwise see you all on Tuesday. Bye, everybody.